a series of 10 lectures on good teaching. I have divided this series into 4 or 5 modules. Module 1 is on tutored video instruction. This has 2 parts, part 1 and part 2, lecture 1 and lecture 2. Module 2 is on electronically networked lifelong learning, or LNET-CL. That is a program which ran for about 5 years at IIT Delhi, not IIT Delhi, sorry, IIT Kharagpur. That is also divided into 2 parts. And then comes basic features of good teaching, which is the core of this series of 10 lectures, or the characteristics of good teaching. I could have given 10 lectures on that, but we have purposely shortened it for the sake of not getting bored into 2 lectures. And the last 2 lectures should not have been last 2, but at the moment they are the last 2 lectures, are on how to measure teaching, and if we can measure teaching, we will find out what are the drawbacks, what are the advantages of good teaching, and why we need to measure good teaching. That makes 8 lectures, and I have left the remaining 2 lectures open for the time being. Now, let us look at introduction to tutored video instruction. The name suggests that it really is nothing to do with good teaching, but in reality it is quite strange. And you will find from the acknowledgement that this acknowledgement is from Professor James F. Gibbons and the TVI team at Stanford University. Professor Gibbons and his team worked on this project, not really a project, but on this work, let us say, in 1974, which is almost 50 years ago. And you will be surprised, or you are probably wondering why I am talking about something which is more than 50 years old and what relevance it may have. It has tremendous relevance. It is surprising. It is incredible what relevance it has. So, I acknowledge to Professor Gibbons and his TVI team. There have not been many papers on this subject, maybe about 5 or 6 papers, and I have read about 5 or 6 papers. Okay. Now, lecture summary. This is a feature which this is a methodology I shall follow throughout. There will be a lecture summary or some kind of indication what the lecture is going to be all about from the very beginning, and then we will set sometimes explicitly, sometimes implicitly, the goals of the lecture, the learning goals of the lecture, and then continue with the lecture and sometimes repeat it. This is the standard procedure we will follow. TVI, lecture summaries. First, we talk about TVI, a short historical background. Then we talk about basic features of TVI. There are many interesting characteristics of TVI. Then there will be a small section on the experiment at IIT Delhi and some observations of the choice of TVI parameters and TVI and good teaching. First, the TVI, a short historical background. In the late 50s and early 60s, there was a lot of concern in the US about the way the industry is going. And people realized that the industry is moving towards information age, and that is quite different from the manufacturing age to which the industry was heading. However, there was not adequate number of people well trained in that area of information age. Electronics, computer science were the areas where a lot of people were required, but there was nothing. So there are a lot of conferences, seminars, workshops going on throughout the United States at that time in the early 60s and mid 60s about how to reduce the shortfall of CS and E engineers in the US. And you could not increase the number of colleges, you could not increase the number of students in the class all of a sudden. So, how to go about increasing the output in these two areas was a major concern. Around this time, Stanford had a convention or a facility which they call the ITFS, or Instructional Television Fixed System, which meant that the courses which were given at Stanford were broadcast using the standard broadcasting technique, and it reached within the 40 miles or 60-kilometer range of the campus. And a lot of students who were working in the industry attended the courses, attended their chosen courses, sitting in their own industry. This was a very satisfactory system, but maybe not as satisfactory as sitting in the real class, but they were quite satisfactory system, and the students did fairly well. Now the problem was that the ITFS could be availed of within 40 miles radius, because that was the range of television because of the Earth's curvature. Now, Hewlett Packard, who was a major employer at that time, had shifted a lot of his research engineers and R&D engineers in a place called Santa Rosa in California. Santa Rosa was 100 miles away from Stanford. So how do you teach these people sitting at Santa Rosa? That became a problem. So the president and the CEO of of Hewlett Packard, wrote to the president of Stanford, "Can you help?" The president of Stanford in turn requested Professor James Gibbons that if he could find a way of helping the students. Professor Gibbons thought out of the hat, and he, after some time, suggested the best thing he could do was to record his lecture during the morning using very low quality VHS video recorder, send the tape to Santa Rosa by courier in the morning. Students could go through that during the daytime, and that would be as near equivalent to ITFS as possible. But there was no idea how it was going to perform. Nobody knew how it was going to perform. Now, with this aim, recording began at Stanford, and the results were, to say the least, surprising, tremendously surprising. What Professor Gibbons suggested actually evolved it wasn't a pedagogic theory which was followed, it was something which evolved over a period of time. What Stanford suggested to Hewlett Packard staff, that they should listen to the tape in small groups of 6 or 8, maximum 10. There was no fixed number in the beginning, whether 6 or 8 or 10 or 12, it was known, a small group. And the learning should be in a small group collaborative form, which meant that the students should be helping each other as they listen to the tape. And how would that happen? That means as you go on, the tape would be stopped, and anybody who could not understand, somebody who could not understand, it should be in a small group collaborative form, which meant that the students should stop the tape when somebody or other did not understand any part of it, small part of it, and they should try and clarify among themselves. It should be collaborative rather than comparative, because there had been a lot of papers at that time which had shown that small group collaborative learning was far better than small group comparative learning, and the group size at the moment was uncertain. The interesting thing about this TVI is it is a methodology which was adopted around normal teaching, which changed into fantastically good teaching. Let me repeat that. There are two kinds of good teaching. One, you have people like Richard Feynman, who come to a class and galvanize a class. There are similar people like that who are fantastic teachers. Give them any subject and they'll teach and galvanize people, and they'll be excited. There are other teachers who are good in their own course material, subject area. They are thorough in the subject area, but they are not necessarily Richard Feynman. They teach well, but their teaching may not be tremendously exciting or interesting. Students may not be galvanized. TVI uses a method whereby an ordinary teacher who knows his subject very well, his teaching is recorded, and the methodology of using that lecture changes the complete nature of the lecture. We will see how that works. So, it will replicate a good teacher. A good ordinary teacher who knows the subject well gives an ordinary lecture, but tutored video instruction builds in the feature of a phenomenal teacher within the delivery method. It is that method which we want to discover. Number two, not only does the teaching become extremely interesting and fruitful, but it also increases educational productivity. What is educational productivity? The problem began by saying that when we required a number of computer science and electronic engineers, there were not enough seats, there are not enough facilities across the US, so we needed more faculty, more students. we needed to produce more students, but we had no alternative. Educational productivity is a way of increasing the number of students without increasing the number of seats. ITFS is one way of doing that. In ITFS, we have the same teacher, one teacher, the same number of students in the class, but effectively by increasing the number of classes where the video is broadcast, the number of students increase. So, that ITFS increases the educational productivity. Let me now show you a graph of educational productivity and a bit more about the. So, we were talking about educational productivity. Now, let us look at this graph, academic value addition and learning gain. I should have added educational productivity along with it. This graph shows the performance of students who are campus students, which are marked by the red dots, and videotape students, which are marked by the green dots. So, how many videotape students do I have? We have 1, 2, 3, 4, 5, 6, 7 videotape students in this particular graph. But later on there are hundreds and hundreds of students. In this particular one, there are 7 videotape students. And what is a videotape student? A videotape student is the one which we had talked about earlier, that somebody who has no opportunity of attending the real class, but the tape is sent to them in the morning. They go through the tape during the day and return the tape the next day, discussing their difficulties for some time in small groups. These are videotape students. There are many other characteristics which will come back later on. So, there are 7 videotape students and their performance has been measured. What does that mean? That Professor Gibbons, after a few days of starting the class, suggested to the videotape students that since you are attending since you are going to listen to the course, why don't you also take the assignments and why don't you also sit for the examinations? So, they were asked that listen to the videotapes, discuss amongst yourself in groups of 8 or 10 for about 6 to 8 minutes. First, listen to the tape for 6 to 8 minutes, discuss for 2 to 3 minutes and continue in that fashion. Anything which you do not understand, leave it for the next day for me to answer. There will be a tutor who should be familiar with the course, but the tutor should not be teaching. We repeat again. Tutored video instructions characteristics in that case is the tape, the classroom is recorded using just ordinary tapes. It's sent out to the people who want to use it in the morning. They listen to the tape in the evening in small groups of 6 to 8, maybe 10. For 6 to 8 minutes. Then they stop the tape, watch it, discuss the problems for 2 to 3 minutes and continue in that fashion. There will be a tutor, but the tutor's job is not underlined, not to teach. The job of the tutor is only to initiate discussions. any points which are not covered, which are not understood, should be referred back to the original tutor, original faculty. In this case, Professor Gibbons. And they were also told that since you are already taking the lecture, why don't you take also the assignments and all the other examinations, short examinations and end of term examinations, and see how you perform. So that is the videotape, students. And what I see here in the green dots is their performance. How do I see the performance? The x-axis here is the admission qualification axis, which means if we look at this student here, at the beginning when the admission took place, her GPA was less than 1. This is 1, that GPA was less than 1, about 0.8. This student, the GPA was, let us say, 0.5. This student, the GPA was 1.8, 1.9. When the students graduated at the end of the semester, because this was a computer science course, MS in computer science course. So, this is undergraduate GPA, this is the postgraduate GPA. That means after they have completed the course, what did they get in this particular subject? How much this student did get? Her GPA was on this scale approximately 0.8, because this represents about 0.8. That was the admission, that was the entry. What was the GPA at exit? Approximately 3.5, which is quite substantial gain. This student's GPA at entry or grade point average at entry was 0.7 or so, but at exit it's 3. Significant gain in GPA. You do not expect somebody who comes in with a very low GPA, but when they go out, their GPA is very high. At this point, let me also point out that in Stanford and in most major good US universities, the admission requirement is such that nobody below a GPA of 2 would get admission. So, this 1, 2, 3, these 3 students would never have got admission at Stanford and MS. In reality, they were not the research engineers, they were the technicians in that particular area. But since it did not cost money to anybody, Gibbons suggested that they may also join in. So, we had 3 technicians who had graduated, undergraduate course they had completed with very low GPA, which meant they were not particularly good students, but they went to the ITFS, not the ITFS, sorry, the videotape mode of instruction, and their GPA was very, very satisfactory, which means 3.4, 3.5, this was 3 little low, this is 4, 4, 5 being almost the maximum. Now, again, let's, before we come to these ones, let's see the other red ones. These are students who are campus students, meaning that they had taken the real class, that completed their assignments, they have taken the examinations, and all that a normal student does in a normal postgraduate course. And look at their performance. The straight line is a mean square fit, best fit mean square, which means the average of these. That's a mean square. It was surprising. Look at it carefully. It's extremely surprising. If you drew a line, mean square line of the grid dots, and compare this with this, you'll find the grid dots are almost a straight line. Excepting these two, they're almost a straight line. Not only are they straight line, but they are straight line and their average is almost 4, which is the highest one could get in an MS course. How did that happen? This was a mystery which drew me to educational technology some 40 years ago. I received this tape, original tape from Professor Gibbons by a colleague of mine, and when I looked at it, I was taken by surprise. How is this possible? That you get in students who are not particularly good, academically particularly good, as shown by their records, but when they go out, they all excel the normal class students, much better. And later on, I'll show you a video and other graphs which will show you that this is not a unique exception of 7 students only. Hundreds of courses, humanities, computer science, electronics, engineering, literature, appreciation of art, Japanese, all types of subjects, the same score. That means we are doing something which is unusual. Not only very unusual, they have added as if that these students are undergoing a course with a very extremely good teacher who is transforming them from their normal course to, from their normal performance to very great performance. The straight line here, if you see the straight line here, let's look at this point, this student whose graduate grade point average, meaning the grade point average at the time she passed out at the master's degree level graduate grade point is this. Where should he have performed? If you look at this mean square line, what does it predict? It predicts that somebody who had a grade point average of 2 at entry should have a grade point average of nearly 3. This is what is expected. Somebody who had a grade point average of 3 at entry should have a grade point average of 3.4. That's what that line implies. But this is not so. In this case, the green dots completely defy that. They are saying it's a straight line, which is extremely surprising. It means that the students who come in with low performance through normal academic channels do extremely well in this method, and the methodology of teaching learning has changed their learning completely. They have all performed at extremely high level. And their learning gain, what is their learning gain? This student's learning gain is she was supposed to perform at this level. That's what this graph shows. But she is performing at this level, that much. So the learning gain is this much. This student was supposed to perform at this level, but performing at that level. So the learning gain, this much. So you find something very interesting, that not only does everybody do well, those who were weaker, like this ones, weak students as measured by normal means, this student and this student and this student, they were weak students because their GPA was 2.7, 2.5, 2.7, and 1.5, 1.7, and 2, they have been performing at this level. So they are learning. So all those students who are weaker, they have done much better than they predicted. But the ones who are strong, who were strong like this one, they also have performed well. They also have performed above their expected level. Above their expected level. This one has performed above his expected level. Above his expected level. So every student has performed above their expected level, but the weaker students have performed well above their expected level. What kind of education system produces that? We do not know of any education system anywhere, from early primary education to postgraduate, where this is done, where this is possible. And later on, I'll show you the results of a group of Japanese researchers who were bright, undoubtedly bright as shown by their performance in Japan research laboratory. They used to perform not so well when they came to Stanford course. But when Professor Gibbons made them go through this, they performed fantastically. They were almost at everybody almost were at the highest level. Why did that happen? The reason why this happened is simple, that they were allowed to proceed in their own at their own speed. This student who could not understand something, and in a normal class had to follow at the speed at which the lecture was going on, could actually stop the tape and reread it or try and understand it once again, could discuss and learn more. That made all the difference. We'll come back to this later on, but you'll see that several things have happened. Tutored video instruction, which allows students to start and stop a tape when they don't understand, discuss it amongst themselves to clarify the points at the appropriate time, do far better than the normal class students. And again, we will see that when they were asked later on if they prefer to go through this method mode or not, everybody almost said yes, they would like to go through this mode.